Models. Um, the first topic in linear models would be quantiles. Now, what are quantiles? Quantiles are points taken at regular intervals from the cumulative distribution function of a random variable. Dividing ordered data into n essentially equally sized data subsets is the motivation for n quantiles. The quantiles are the data values marking the boundaries between consecutive subsets. Now here we have some quantiles. I mean, they've been given special names. So for example, a 2 quantile is called the median, a 3 quantile is called a tertile or a tercile. It's represented by the capital T. The 4 quantiles are called quartiles, the 5 quantiles are called quintiles, and so on. The 1000 quantiles are called permulages and represented by a capital P and a small r. So these are the names. Some special names have been given to specific quantiles. Okay, now here is the MATLAB function which we will use to calculate quantiles. It is quantile. So y equals to quantile x comma p would return the quantiles of the values in x. P is a scale or a vector of cumulative probability values. When x is a vector, y is the same size as p, of course. And when yi contains the pith quantile, when x is the matrix and the ith row of y contains the ith quantiles of each column of x. For n-dimensional arrays, quantile operates along the first non-singleton dimension of x. Okay, so here are two examples. As we read that a 2 quantile is called the median, so y equals to quantile x comma 0.5. This would give us the median of x, and I mean this quantile is called the median quantile, and y equals to quantile x comma 0.25, 0.25, 0.025, 0.25, 0.5, 0.75, 0.95. I mean, this is a summary of x. So here are two examples on about quantiles. Okay, now we come to least squares fitting. Now this is a mathematical procedure for finding the best fitting curve to a given set of points. We will learn how we will learn curve fitting in the next tutorial in nonlinear models. So this is the best. This is for finding the best curve fitting to the given set of data points by minimizing the sum of the squares. Now this can be done in two ways. It will either be perpendicular to the curve, or it can be maybe horizontal or vertical. So that we'll see in the coming slides. So and by minimizing the sum of the squares of the offsets, that is the residuals of the points from the curve. So here we have this diagram. We can take vertical offsets, or we can take perpendicular offsets to the curve in the least squares fitting method. Now in practice, the vertical offsets from a line, this polynomial, surface, or a hyperplane, etc., are almost always minimized instead of the perpendicular offsets. And two important functions provided by MATLAB are mldivide and mrdivide. Now mldivide and a comma b and the equivalent a by b, that is the a backslash b, perform matrix division left. And a and b must be matrices and have the same number of rows unless a is a scalar, in which a backslash b performs element-wise division. That is a backslash b equals to a dot backslash b. Similar to this, we have the mrdivide b comma a and the equivalent b forward slash a perform matrix right division. So that is b forward slash a, that is the short form or the substitute for the function mrdivide b comma a. Now b and a must have the same number of columns, of course. And we have this generalized linear models, which we also studied in the regression tutorial. Now linear regression models describe a linear relationship between a response and one or more predictive terms. Now many times, however, a non-linear relationship exists. Now non-linear regression describes general non-linear models. Now a special case of non-linear models known as generalized linear models makes use of the linear methods. So this is about linear methods. In the next tutorial, we will learn about non-linear methods and curve fitting.